This video is about water sampling in general and the operation of water quality field meters and continuous water quality meters. The aim of studying water is that the conducted measures represent the target water bodies and the situation at the time of the study as well as possible. The studies can include chemical, physical, biological, and microbiological assays in a laboratory or using field kits, for example. However, the methods and instruments used always depend on the aims. Water studies involve several special considerations that affect the planning of sampling and fieldwork. The weather, seasons, and the changes in water level are important factors affecting water and its quality. Water can also be layered, and the water quality of the different layers can vary greatly. Samples taken at the same point from different depths can therefore provide very different results. The key to water monitoring is a good knowledge of the region and taking the aims into consideration. It is important to look at each sampling site as an individual case with its distinct properties. When investigating areas, you also need to look beyond the water, into the catchment area. The reason for a deterioration in water quality can often be found in the catchment area. When planning sampling and measurement points, the mobility of the water should also be considered. The points should be against the direction of the flow, from the lower to the upper reach. This ensures that any disturbance in the water caused by the work does not affect the points below the flow. The time differences between the observation points should also be considered. Substances that end up in the water are carried by the flow of the water. It may therefore take hours or even days before the substances are detected at later points downstream. Observations made at the same time at different points do not therefore apply to the same water. Knowing the flow volumes and rates and the resulting retention time is therefore an important part of water sampling. There are various methods for studying the state of water bodies. This video looks at 3 methods: sampling, water quality field meters, and continuous water quality meters. The suitable method and analysis should always be selected based on the aims and resources. However, one method does not rule out the others, but they should be used together to support and verify each other. Sampling is the most typical way of studying the state of natural waters. Water is taken from the desired point and sent to a laboratory for analysis. The laboratory can analyze almost anything from water samples according to the needs. What is analyzed from the samples may affect, for instance, the sampling depth, the material of the sample container, and how the container is filled. There are several ways to fill a sample container. Containers can be filled by hand, but you need to make sure that the hands of the sampler do not contaminate the samples. In some cases, the use of extension poles can make sampling easier, particularly if the sampling point is difficult to get to or you want water from a certain depth. Luminous samplers that can be lowered to the desired depth can also be used in sampling. The sampler is activated with a weight which closes the hatches, allowing the water sample to be lifted up. In all sampling, it is important to disturb the water as little as possible. For example, sediment that mixes with a water sample contaminates the sample entirely and it no longer represents only the water at the sampling point. Such a sample should not be analyzed. The samples must also remain unchanged until the analysis. In some cases, the sample should be fixated immediately after taking it. For example, when studying oxygen content, it is important to precipitate the oxygen with fixation chemicals. This is to prevent oxygen from escaping the water sample. There may be hours or even days between the time of sampling and the final analysis. Fixation is therefore important to obtain reliable results. A sampling record should also be written with not only the sample data, but also essential factors that may affect the results, such as the weather conditions and the time of sampling. The temperature of the samples at the time of sampling should always be measured immediately and written down. It is impossible to determine the temperature afterwards. After sampling, the samples should be stored and transported appropriately. Sample containers should be padded to avoid breaking and protected from light and temperature variations. A good way to protect and transport samples is a cool bag with enough padding. The analysis form should also be placed directly inside the cool bag. This ensures that the laboratory will know what the samples are and what analysis should be done. The nature of sampling can therefore vary greatly depending on where the samplers are taken and how they are analyzed. It is therefore important that the sampler knows the aim of the study and uses the right methods in fieldwork. As their name implies, field meters are instruments carried by the sampler to the field that are easy to move from point to point. Meters provide measurements directly from a measurement point without sampling and laboratory analysis. Meters have sensors that are designed to detect a particular water quality parameter. The sensors can be, for example, optical, electrochemical, or potentiometric. There are several different meter and sensor assemblies, and their suitability for the target site should always be considered case by case. When using field meters, a single measurement usually takes only minutes or a few dozen seconds. The sensors should first be allowed to stabilize in the water to be measured to improve the quality of the measurements. Although measurements can be taken quickly and easily, the measured data are only general water quality parameters for monitoring water quality. This means that you cannot directly identify, for example, contaminants or their concentrations based on the results. However, the measured parameters can provide correlations with other parameters. For example, the amount of phosphorus can be estimated based on the turbidity measured by a meter. The reliability of the measured results should be verified by calibrating and maintaining the meters regularly. Calibrations should also always be done for each individual measurement site. For example, calibration done in fresh water may not be suitable for measuring seawater. In addition, pH sensors may require even daily calibrations to obtain reliable results. The accuracy of the results should also be confirmed by taking periodical samples. The results of the meter should not differ significantly from the sampling results. The functioning and calibration of the meter should always be ensured before fieldwork. During measurements, it is important to make sure that the sensor heads of the meter remain clean. The results should be monitored constantly and any inconsistencies should be addressed. The collected measurement data can be downloaded from the instrument to a computer where it can be processed. Since measurements are easy and quick to take, and one measurement can provide up to dozens of measurement parameters, even one field visit will provide a lot of measurement results. Often this means the statistical review of the results and the processing large volumes of data. The person processing the results should also be able to examine the results critically, know the measurement uncertainties of the meters, and remove any measuring errors from the results. The equipment should also be maintained after use so that they are ready for the next measurement session. The principle behind continuous meters is the same as with field meters, but instead of being portable, they are left at the desired point to take automatic measurements using battery or plug-in power. Continuous meters can work by saving the measurement data in an internal storage space from where the results can be downloaded after the measurement period. Or the meters can also be equipped with transmitters that send the results in real time to be read remotely. Due to automation, measurements can also be taken at points of time when field visits by a sampler would be challenging. For example, changes may occur in water quality at night that would otherwise be left unnoticed. Since the meters remain in a fixed target location for weeks or even months, the choice of measurement location has a direct effect on the representativeness of the results. The devices are also often left unguarded, so they should be protected, both from nature and from vandalism. Since continuous meters are used in the same location for long periods of time, their regular maintenance is particularly important. Natural waters often contaminate sensor heads, which may decrease measurement accuracy. Some meters also come with automatic cleaning brushes to prevent contamination. Despite cleaning brushes, the devices should still be maintained regularly. Just like field meters, continuous meters should also be calibrated and verified by other methods, often enough to ensure high-quality measurement results. Continuous meters provide huge amounts of measurement results. For example, if there are 10 measured parameters and the device takes 24 measurements a day, this means 240 results per day, 1,680 results per week, and 7,200 results per month. Enough time and know-how should therefore be reserved for processing, examining, and interpreting the results. As with field meters, obvious errors in measurement should be identified and eliminated. Although there are several methods for studying waters, they do not rule out each other. Sampling is the most important and reliable way for observing the environment, but it is also a time and resource-consuming method. Moreover, sampling does not necessarily allow for observations from multiple sites and at frequent intervals. These gaps in observation caused by sampling can be filled in with field and continuous measurements to provide a more extensive overall picture. Meters, on the other hand, provide many observations, but only concerning general water quality parameters. Meters support sampling with the number of observations, whereas sampling supports meters with the quality and accuracy of analysis. This enables the combination of quantity and quality and the formation of a comprehensive overall picture with observations. Whatever the methods used to study waters, it is important that the achieved results are of high quality and compatible with the aims and that they allow the necessary conclusions to be drawn to preserve water quality.